Good evening, ladies and gentlemen. My name is Vardhan, and on behalf of Edureka, I welcome you all to this session on what is DevOps. So, based on several requests that we got in our previous sessions, we are conducting this live session which will give a basic introduction to what DevOps is all about. So, guys, during the session, if you have any doubts or any queries, don't hesitate to put them in the comment box because we have a team. I have a team with me, and either they or I will myself answer them for you. So just sit back and relax and enjoy this session for the next 30 minutes to understand what exactly DevOps is and to clear all your doubts. Alright? So, before I start with the session, I have a question for you people. Can anyone tell me which are the most common software development methodologies today? Okay, so you guys can answer that. Some of the most popular development methodologies that have been there over the years are those of SDLC, Agile Development, Scrum, and of course now it's DevOps, right? But what exactly is the need for DevOps, right? DevOps is the most latest and by far the most efficient, right? Why is it that what caused DevOps to become so popular, and why was there a need for DevOps? Let's look at that first. Okay, that'll be the first topic for today. We'll look at the different challenges with software development. Okay, and then I'll tell you how does DevOps minimize that challenge. And after that, I will talk about the DevOps tools and techniques, which of course help us in enabling and achieving orchestration between the different DevOps tools. And that's actually the best part of DevOps, implementing the different tools, making a job easier, achieving automation. So that will be another important topic that I'll talk about. And then finally, I will talk about what is the demand for DevOps engineers before finally giving you a hands-on demonstration of a DevOps engineer in action. Okay, but this again is not going to be a very detailed demonstration. I'm just going to use two tools in Git and Jenkins. I'm going to show you a basic demonstration of how these two DevOps tools, which are the most popular DevOps tools out there, how they work and how easily we can benefit, right? So that will be the agenda for today. So without wasting much time, I'm going to start with my first topic, and that is the software development challenges. So the primary factor leading to challenges during software development is the silos that exists between the development team and the operations team. Okay, and as you can see from the image here, it's a very similar scenario out there in the industry where you have the development team on one hand and the operations team on the other hand, and they always have tussles. So they always take blows at each other, and they always have disagreements, and they point fingers at each other whenever there is some kind of a mishap that happens. Well, that's because the developers are responsible for just developing the code and testing the code and then giving it to the operations team. And then it's the operations team's responsibility to deploy that to the staging server and then to the production server, and then finally, release it, right? And over here, where the problem actually comes up, if there is any problem with respect to the code, whether there being a faulty bug in the code, then in that case the operations would start blaming would start putting all the blame on the developers. And in fact, if there's a problem on the operations side where if they're not able to deploy the code properly, then the developers would start blaming the operations there. So they would start saying that you don't have the system in place, you don't have the right dependencies, you don't have the right tools and all these things. So it's a blame game that happens between the two, and it's one thing which has been which has a bad effect on software development. So a lot of projects gets delayed, and there is very inefficient planning, and all these things happen. Now to eliminate this is what we have something called as DevOps. Okay. But before I go into more details about DevOps, let me talk about a few more challenges and problems that these people come up with. So as you can see here, the developers, besides just saying that, they also blame the operations for having legacy systems, because the operations would say that they cannot move everything to a new system. They need a lot of time, and there's a lot of dependencies, and just too much is there at stake for them to leave their legacy system, right? And that is a problem that the developers would have, because the latest technology that they would be developing, that cannot be run on legacy systems. That need like really good and really latest hardware and technology there. And then the developers also complain of tool turbulence. Now what we mean by tool turbulence is that some set of tools which the developers would have used to develop an application or a software that cannot be implemented on the production server. And the reason that could not be done is maybe because of security risks or firewall or many other reasons. It's just not possible to do to deploy that in production server, and that's where the operations would have a problem. So after the developers build everything, then they would the operations would complain that they cannot implement this tool, and the developers would have a tussle, and they will have to probably rebuild the software from scratch. So that's one aspect of that's one aspect of the problem that they face. Okay, and developers most often complain that automation needs to be in place, because a lot of automation helps in a big way. It reduces a lot of tasks. Okay, being the technical guy, being the technical people, they know how to achieve it, but the operations would not always coordinate with the developers on that aspect. So that's one more complaint that the developers would have. Now, going to the operations people, those folks would start complaining that since the software or the application is developed by someone else, them monitoring it on their own is a little tedious, right? So that's one complaint that goes out, and they say that then there needs to be efficient monitoring, and even the developers have to be equally responsible for how the software is performing. If there is any bug in the code, then they should be able to fix that bug right away, because if it's not fixed, then there is the onus is on the operations, right? So they are going to be held responsible. So they would be asked to fix that. And besides fixing bugs, there's no way to revert back the changes. So with operations, their hands are tied in that place. And finally, the operations would also have problems in the production environment, like I told you earlier. So they would have different set of dependencies and libraries installed in their system, and the developers would have developed the application based on the latest software. They would have updated to the latest dependencies, and that is something the operations would not have done. And that may be a reason why sometimes the application does not work well on the production. Some features might not work even though it's working perfectly at the developer's end. So developers would be complaining that it's your system that's not that's causing the problem, and the operations would say that no, it's your code. So this is a very common analogy that comes with the software development challenges over the years, and this is what has caused DevOps. Okay, and as you people know, you people might be aware of the solution to this right now, right? So it's pretty simple. Since there are two different teams here working separately to achieve a common task, they have this chance to blame each other. But if you merge them, you have the problems goes away, right? So dev and ops together, DevOps solves all the problems, right? So that has to be the solution. I hope everyone here agrees with me. So on that note, I'll go forward, and now let's see what is the DevOps strategy and what are the folks here that are working as DevOps engineers, what is their responsibility. So DevOps engineers would not just be taking care of one aspect. They would not just be taking care of development, or they would not just be taking care of operations. They would have to take care of the entire life cycle. Okay, they have to be part of the planning, coding, building that software, then testing it using different tools. Then they have to deploy to production, perform the operations on that, and finally monitor how the application is performing. And finally, whenever there are changes, and with the next cycle, with the next release, they'll have to integrate those changes with the existing system. And this is a never-ending cycle. So this is what DevOps engineers need to do. Okay, and that is the same image that you can see here. So there's a DevOps engineer that's working on a system that's probably coding, and then he's the same person here. He's also working on the operations aspect. So he's getting all the reports and all these things, right? So the DevOps strategy, since it involves the engineers to have complete control of the application that's being developed, it involves continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring of the software throughout its development lifecycle, right? So that's what the DevOps strategy preaches. That more responsibility needs to be taken up by these folks who are DevOps engineers. So the developers can't complain that it didn't work on production, because they are now going to be responsible for that. And since they are going to do it, so they will be able to immediately know where the bug is, why something's not working on production, and if something cannot be deployed to production, then what are the alternatives? They can fix that. And with the help of DevOps tools, there is also scope for reverting back the changes, right? We have version control systems which can be used to go back to the previous state and achieve a lot of automation and save a lot of time and benefit over the other development methodologies. So now that we've spoken about the DevOps strategy and what the DevOps engineers are expected to do, let me go to the next slide and talk about some of the most popular and used DevOps tools. So these are the most moving tools in the market, and we have different categories. So the same: plan, code, build, test, integration, deploy, operate, and monitor. They are divided over various phases. So the plan and code here, we have three different tools in Git, SVN, and Jira. Okay, this subversion is also called as SVN, and these three tools are basically version control tools. Okay, and they fall under this plan and code phase because as version control tools, what they do is they enable developers to write the code and build the code over here. Okay, they can plan and they can code as per they wish to, and they can make changes to it, at free will. So it's not like they write a set of code today and they make changes tomorrow, and they can't revert back. So that's the thing with SVN. They don't have to worry about that. So even no matter how many changes they make to the code, they can always revert back to a previous state, because the version they would have committed to the SVN system or the Git repository, that would be tagged with a version. So if they are not happy with any version that they have released recently, or if there's any bug over here, then they can always revert back to the previous state, which was stable. So that's what these three tools can do, and that's what they do as continuous development tools. Okay, and for building, we again have tools like Maven and Gradle. Okay, now these three tools are for building, and even they follow they are actually part of the continuous testing phase. Okay, they are used with the testing tools, and the main responsibility for them is to use whatever code has been built, right? So it would just package that and it would be ready to build for testing. So that's the responsibility of these three tools. And going on, the second part of the continuous testing phase involves these tools of Selenium, JUnit, NUnit, TestNG. So these are the testing tools which would actually do the test. So this testing phase and the building phase, they together form the continuous testing phase, continuous testing part, right? So in the continuous testing part, the code is built and it's tested. So the actual testing happens here. And whenever the code is a success, or whenever it's a failure, then that can be worked upon, it can be improved, or it can also be integrated, or it can be deployed. So this deployment happens with the help of for deployment, there is this phase of integration, and the integration that you see here is one of the most important phases, and the tool that we use for integration is that of Jenkins. So Jenkins is probably my favorite tool because of what it can do, and it is what encompasses the whole DevOps methodology. Okay, so it's at the heart of the DevOps strategy, where it integrates everything. So if there is a new code that needs to be deployed, Jenkins can do that for you. If there is if your code suddenly stops working, then Jenkins will be there to notify you of that problem. And if you want to make changes to the existing code, then Jenkins can do that for you. It can do the integration. So it can do monitoring. So Jenkins is an all-in-one tool. It can do a lot of things with integrations and plugins to a number of tools here, right? So, and Jenkins, its main integrations are with those of Selenium, Maven, Git, and the configuration management tools. And of course, we're not talking about Docker here. So Docker again is a really, it's one of the best deployment tools which containerizes your applications, right? So that's what is the big benefit with Jenkins. So it basically blends in well with all the other tools. And then we have the deployment phase and the operation phase. So this forms the continuous deployment phase. And over here, these four tools of Puppet, Chef, SaltStack, and Ansible, they are the configuration management tools. Okay. Now, as configuration management tools, what they need to primarily do is to deploy all the code and basically to deploy the code and the application to a number of servers. So so what happens in the industry is that you will have to deploy your code or host if it's a web service, you have to host it on multiple servers, right? You need to enable you need to have high availability, and besides high availability, it needs to be accessible by a lot of traffic, since there'll be a lot of load coming in. It needs to be managed, so you'll need multiple servers. And if it's fine, it's possible if you're having to host just 2 or 3 servers, you can probably manually do it. But if you want to scale it up to 50 servers or 100 servers suddenly, so at that time you will have problems. And even doing it once is fine, but if you want to make minor changes to the code that is deployed onto these servers, then it's a problem, right? So that's where these configuration management tools come in. So with these tools, you can easily deploy these code changes and deploy the code itself from scratch on any number of servers. So they are basically, they work on the basis of master-slave architecture, where with the help of master, we can deploy the code to multiple slaves, and each of these slaves would be the different servers. So that's what the continuous deployment phase comprises of. It holds the deployment and the operation as a part of it. And finally, here comes the monitoring phase. It may be the last, but it's certainly not the least, because it is the monitoring phase which tells if your application is working perfectly, if it's all fine, if there's any downtime, if something fails, if something grievous happens, if your system is not working. All these errors would be you would know only with the help of monitoring, right? So you have to always have a look at how your application is performing, and the tools for that are those of New Relic, Sensu, and Nagios. So these are some of the most popular tools, and yeah, that's how they work together. They work in tandem, right? So any doubts, guys? Do drop in. If you have any doubts, do let me know at this point of time. Guys, so I'll just give you people a couple of minutes to put in your questions. Okay, so I'm just going to mute myself till then. Okay, so there's an interesting question here from Bhupati. He's asking, in the future, would there be no jobs for test engineers? Well, Bhupati, it's not like that. So you would definitely have openings for test engineers. They are also a part of this DevOps lifecycle. Okay, so the DevOps engineers would also be doing that part, and it would not be just different phases. So like I said, DevOps comprises of a lot of things, and they would all be working together. So you will have to have multiple skill sets. So gone are the days that you can just sit on one particular fruit and enjoy the taste. So you'll have to have multiple skills. So that's how this happens. Okay, so guys, anyways, let me get back to my session here. Okay, let me continue with my session. So I'll take up more questions later on. So yeah, there's just one more slide here before I go to my demonstration, and that is what is the demand for DevOps engineers? Okay, you guys might have by now realized how DevOps is the future. So there is some more proof here, and as you can see, some of the top companies over here in HP, Tesla, SAP, Cisco, and Amazon, they're all hiring DevOps. And it is these DevOps engineers whom they are rapidly looking to, groom and hire. So if you look at HP, they say that they want to build a DevOps solution using relevant tools, because of course they are a big MNC, right? So they have various services, and absolutely it makes sense when they say that they want to make use of multiple DevOps tools, and it's the engineers who would be doing that for them. And Tesla for advanced system engineering, SAP for end-to-end DevOps strategist. Well, this is another interesting thing. because there is just so much to do with DevOps, and it's an unexplored field. It's still young, and there's so much that you can do as a DevOps strategist. And yeah, SAP are just doing that, and this shows that how important these DevOps engineers would be for them. And same thing with Cisco and Amazon. They are trying to implement virtualization using DevOps. So this is just I've just given you a basic idea of how the demand for them is. So I've not even included all the software service companies here. I've not included any of these startups. It's just some of the top companies. So to just give you an idea of how the demand is. So well, in the meanwhile, I can go to my demonstration, because that's the end of my slides. And to go to my demonstration, what I need to do first is I need to open my virtual machine, right? So guys, do give me a confirmation if you can see my virtual machine. Can you see it, guys? Okay. Alright, so please bear with me, my VM is a little slow. But anyways, the demo that I'm going to show you is basically using the two tools of Git and Jenkins. Okay, like I told you, Git is going to be used for storing my code and pulling the code to basically be stored as a central repository for my code, right? And my Jenkins here, I will use Jenkins as the tool that would pull my code from Git, and it would deploy it or execute it. It would build jobs based on the code that is there in Git. Okay, so let me just show that implementation on my system. So this is my VM, this is my terminal. Okay, so I'm here. Let me just cd to the Git repository. So here you can see that there is one hello world file, and then there's a readme file. So the readme file comes with your Git repository. So if you initiate any repository in Git, a readme file comes with it. And my hello world file here, let me just do a cat and show you what is there here. So it's a simple batch file which I've created, which says Hecko hello world and Hecko hi from Edureka. Okay, now it's a very basic demonstration, and I'm not going to go into details of how the code is being managed over here and how it's going to be deployed. I've done that in some of my previous sessions where I've showed you how to deploy an Angular application, how to deploy a main stack application, and all those things. So this is a basic session where here I'm just going to show you how Git and Jenkins can be used together. Okay, and Git being very popular and one of the most important or the fundamental tool for code development, I'm going to show you how that happens. So this is what is there in my batch file, and if I execute it from my terminal, this is the output that you get, right? So even when I run my, well, what I did here is I did cat hello world. So if I want to execute this batch file, I do a bash and hello world.sh, right? And for those people who don't know what bash is basically to this is used to execute any shell, any batch file. Okay, and inside the batch file, commands would be specified, and whatever is specified, that would be straight away executed. So if you see here, I've said echo hello world and echo hi from Edureka. Okay, now when I did batch hello world.sh, these two commands were simply executed. Okay, the echo command simply executed hello world, and in the second line, the echo command simply executed hi from Edureka. So that's what a batch file does. A bash file does. Okay, and executing this through Jenkins is what I'm going to show you. But before I show any execution over there, let me first show my GitHub repository. Okay, so using my Jenkins, I'm going to pull this code from my GitHub repository. So as you people are aware, this repository of mine /home/edureka/git repo1, this is a Git repository, and this is linked to my URL at this one, github.com/vardhanns/hello world. Okay, so we have the same file over here, the hello world.sh, and as you can see, we have the same two lines, echo hello world and echo hi from Edureka. Now I want to show you how Git works. Okay, before I show you something with Jenkins, I want to make changes to this code and show you how I can push code using Git. And when I push code from Git, those changes would be also tracked in my GitHub repository. Okay, and from the GitHub repository, I can use Jenkins to execute this code. So what happens in the industry is, whenever such code is being developed, it will be developed by a lot of people, right, at the same time. So you will have say 5 to 6 developers working on the code, and they will all be making changes and developing their own code. And as and when they make changes, and as and when they develop a couple of lines of code, they will be pushing it to GitHub. And from GitHub, the final code will be sent to deployment. It would first be tested and then sent to staging server, and then it would be released to production. So basically, GitHub is used as the resource from where the code is managed centrally. And yeah, people can connect to GitHub from their local systems itself. So as a developer, look at me in action. See what kind of changes I make to my GitHub repository and how I push my changes to the GitHub, and then I'll show you how that can be executed through Jenkins. Okay, so first of all, if I want to edit this file, let me do a sudo gedit hello world.sh. Okay, and this is the password. Okay, so I don't want to make major changes, so let me just let me enter another echo command and say your instructor is Vardhan. Okay, I'm going to save this. So there's an extra line that I've added here. So even if it's with respect to any Python or Java application, any kind of change you make to that code, that can be saved like this and sent to GitHub in a similar fashion that I'm going to show you now. Okay, so now that I've added my code here, what I need to do next is I need to do a git add command. Okay, so this would basically track all the changes that you do. Whatever you add, all that would be tracked with the help of the git add -a command. Okay, and if you want to commit your changes, then the command for that is git commit with a m flag, which basically is to specify any comment. What is this comment for? So I can say that this is the third line which I've added, something like that, right? And I can say this is the build number 3 or something like that. I can hit enter. So this is just the comment that would be associated with this git push of mine. Okay, and to actually push your changes to your GitHub and to get the changes there's this command called git push origin master. Okay, so this would push whatever changes you have locally. It would push that changes to the GitHub repository. So it will take a couple of minutes. So let's just wait till then. Okay, the username is this and my password is this. Okay, maybe my password was incorrect, so let me just try hitting the command again. Or maybe there's a problem at the GitHub server, so let's not worry about that. It should be fine by just executing it a couple of times. Okay, there goes the username. Okay, great. So counting my objects, compressing them, pushing them, done 100%. So let's wait for the status. Okay, great. So whatever changes I made has been committed and sent to my GitHub repository. Okay, hello world.git. So in a similar fashion, so developers will have a single repository for their software application. Okay, and in that private repository they can develop the application and keep making changes to it, and then through Jenkins they can deploy that code. Now, to verify if my GitHub has the updated code, let me go back to GitHub, and let me refresh this page, which displays what's there in hello world.sh. A new line should appear over here, right? Okay, seems like the internet is a little slow, but anyways, that shouldn't be a problem. Great. So the third line has also come in here. So my GitHub repository has the updated code. Now it's all about Jenkins, right? Now Jenkins is always by default hosted on port number 8080. Okay, so if you do a localhost colon 8080, then you can access your Jenkins web server. And I don't think you people need to know anything more than Jenkins being a web server which helps us pull code from Git, and it helps us execute tests through TestNG and Selenium. It helps us containerize applications with the help of Docker. It helps us work with configuration management tools like Puppet, Chef, Ansible, SaltStack, and of course it helps us in automating a lot of things. But getting back to our session for today, the Hello World build. So this was the project that I created. So let me just click on this. And here, to save some time, I've already added my GitHub repository here. So let me just run through those changes, what I did, okay, to help you understand what I've done. So under configure, if you go to configure, you can make changes and you can add your project details, okay. Okay, so first of all, under general tab, you can add the project name, some description if you want to, and in case you want to execute some file from your local system, then you can click on this advanced tab and say use custom workspace, okay, and then you can add the path over here. But since I'm executing this through GitHub, I'm not going to do that. I'm just going to quickly go down. I'm going to say source code management. I'm going to say Git repository, and I've specified the GitHub URL, okay, /helloworld.git. That's where this is present. My hello world bash file is present under this repository, right? So that's what I have entered over here, and you can just quickly go down. And under build triggers, you can control how you want Jenkins to execute. Well, the actual concept of automation can be achieved over here. Okay, if you want to, trigger builds remotely, you can choose that option. If you want to, build some trigger of this project after some other projects, then you can do that too. If you want to build this particular, job on a regular basis, on a periodic basis, then you can do that too. If you say build periodically, then you can in cron period, you can in cron format, you can specify once in how many hours or once in how many days you can execute this file. You can say that, or whenever there's some kind of change that you push to GitHub at that times, if you want Git to execute, if you want Jenkins to build this job, you can choose that by checking on this, and various other options you have. Okay, so the automation concept is achieved over here, build triggers. And then you have build environment, which we don't really need to worry about now, but the actual build. So here is where you specify what you want to execute. So I've given the repository of my GitHub account, and over there is this hello world.sh file, right? So the same command which I executed on my terminal, I'm saying Jenkins to execute that same command over here. So in my shell, I would be executing the bash command, and the file that I would execute with the bash command is the hello world.sh. Okay, it's as simple as that. So when I just build this job, then I would get the same output I got on my terminal. Okay, I would get a hello world. Now let's see if that happens. So for that, we need to go to build now. So I'll say I don't want to save any changes. And yeah, you can see build now option over here, right? Above configure. So you can click on build now, and your your job is would probably be getting built now, right away. So the build number 16 is scheduled, and if you click on the drop down and if you go to console output, you will know what is the status. Is the build successful? Is it not? And all these details you'll get. So great, it's a success, right? The finished state is a success, and the same three echo commands that I had specified in my bash file, they are executed here, correct? So in a similar way, if there's any application that you have, if it's a Java program or if it's a Python program, or if it's any kind of web service that you're hosting. So in my previous session, it was Angular, it was Angular, and then one other time I executed mean stack application. So these were the things which I executed through Jenkins and Docker, right? So similarly, I've done it here, but today is a very simple command where I've is with a simple command I've executed a bash file. But what you need to understand is this is how Jenkins can be used in the industry, right? And this eliminates a lot of problems. There's a lot of scope for automation, and there are a lot of benefits with this. So yeah, that pretty much brings an end to my session here. So I can just wrap up my session by going back to my slides here. And guys, do drop in your questions. I will take them in a couple of minutes. Sorry. And yeah, these are the topics that I covered. So I spoke about the software development challenges that are there that used to exist with the various models, and then I spoke about what is the role of a DevOps engineer and how the DevOps strategy, what are the phases involved over there, and then I told you what are the different DevOps tools and the different techniques to achieve automation, and then I finally spoke about the demand for DevOps engineers. So before I take up your questions, I want to just quickly show you this. I want to show you this survey form, and the link of this survey form is something that you would find in the comment box, okay? And it's really essential and really important you fill this form if you want to avail exclusive discount on any Edureka course, okay? And since you've been in session for so long, you're getting this link. So do take the small trouble of filling up these details, and yeah, so next time whenever you're buying any course from Edureka, you can be rest assured that you're going to get a whopping discount on the course. So that was that, and then we have a YouTube playlist filled with a number of DevOps videos. You can check them out. You can like them, subscribe to our channel, and follow our videos, like them and share them. You can also check out our DevOps blogs. Okay, so we have a number of blogs here on each of the different tools, on Git, Puppet, Chef, Ansible, on Docker, Jenkins. And you also have an interview questions blog here. So if any one of you are interested, and if you are aspiring to be a DevOps engineer, I would recommend you to go through this blog here. Okay, do that, and finally you can check out our DevOps course at this link. So you will find other details of our course with with respect to the course details, the pricing, and all these things over here. All right. So that's the thing, guys. Now let me just see what kind of questions I've been asked. So yeah, there's a question here that says that clear on Jenkins, but there are multiple monitoring tools like SolarWinds, Nagios, PRTG, BMC, etc. So why are we sticking only to Nagios? We are not just sticking to Nagios. Nagios is actually it's the most comfortable tool. It's actually my most comfortable tool. Okay, it's one of the best, and you can implement the other tools also. So it's all up to you and your requirements, right? So all these may be good enough. So it's, if you feel any, you feel if it's important, you can execute and you can use them. All right. And okay. I have another question here which says, when will I conduct a live Azure admin class? Sure. Shri will have it very soon. Thanks for your question. So I would send this feedback to my team, and we would have one very soon. We have another good instructor for that, and we'll make sure that happens. And there's another question. Jenkins is used for development. Nagios is used for monitoring. Well, SK, the thing is, Jenkins is not used for development. It's used for integration. So whatever you develop, Jenkins would help you integrate that to your production server. And if there are any changes, it would help you integrate even those new changes to your existing servers or to your existing code. Okay. So Jenkins plays a middleman here. It's the broker which enables automation. And you're right with respect to Nagios. It is used for monitoring. Okay, so seems like there are no other questions. They're very basic questions, which will of course be answered by my team. I think on this note, I can end today's session, right? Yep. So, guys, it's been a pleasure. It's been a pleasure with you people. Thank you for attending this session. We will come up with more live sessions. One definitely for Azure. Do subscribe to our channel, like, comment, and share our videos, and it'll be a pleasure to have you on board with us, guys. So, thanks once again, and happy learning. All right.